Good afternoon, I am Mr. Ish. Thank you for joining me. I've presented this video before, surface area of cylinder, but I've presented in a different format. I will include the tag of that video with this video and you can see what that alternate route is. Here we're looking at everything with regards to some sort of a rotational dynamic, and I had a specific request from a viewer to present it in this manner. Hence, I'm presenting this route of cylinder, surface area formula derivation. You know, if you're looking at a cylinder, you can look at it in this way. I'm not doing 100% accurate depiction, but you know, you would make this three-dimensional. From the very beginning, just understand you have this surface which is pi r square. We have that surface right here which is pi r square. You combine these, we're looking at a 2 pi r square. The only thing which remains now is this specific cylinder part is what we have to look at without looking at the ends. We'll add the surface area of this cylinder to this. There's no need for me to show you the derivation of pi r square and pi r square. We know that. But this is what we're looking at. And I'm focusing everything here with regards to dx. I'll show you the formalized way and the very intuitive way. The very intuitive way is what we're looking at first, and it's very easy. Imagine you have a finite cylinder along and parallel to your x-axis. We're looking at a certain radius dimension away. We're looking up here at a certain radius, and its radius is here, y is equal to r. That will be my radius. And I'm cutting the cylinder off here by means of an imaginary vertical line, and this will be x is equal to h. If I were to look at this, remember, do not confuse this for the integration of an area along your limits, because when you're looking at volume, we're integrating here a circumference along your limits. You have to look at everything with regards to a circumference. If the radius here is called r, our circumference is 2 pi r. It is this circumference which will now integrate along the lower limit to the upper limit. The cumulative effect of this circumference from here to here will give you your surface area of this cylinder portion, not counting the ends. So that's all there is to it. We have 2 pi r. Our lower limit here is 0, our upper limit here is h. Along the x dimension, we have a circumference coming into play, which is 2 pi r with regards to dx. This is all you have to integrate. All of this can come out right here. We're looking at 2 pi r from 0 to h dx. Bring out your hidden antiderivative, which is x. We have 2 pi r, we're looking here from h to 0. When you do your definite integral procedure, the actual computation you're getting here 2 pi r h. This 2 pi r h will add to this right here, and that will be your surface area of a cylinder. 2 pi r h plus 2 pi r square is equal to surface area of a cylinder, and it should be good. That's your intuitive way. Now your formalized approach. Surface area with regards to x, you have a formula already available. You're looking here from a to b, we have y, then we're looking at 1 plus dy over dx. All of this is square with regards to dx. That's your surface area of a cylinder formula, the integral formula along the dx. What is my y? Y here is your f of x. What's your f of x? It's this, y is equal to r. You have a 2 pi. You're again looking from 0 up to h, which is this value right here, 0 to h. You have your y, which I've told you is your r. You have a dy over dx. If y is equal to r, then dy over dx is equal to the derivative of a r, which is a constant, which is 0. You'll have 1 plus a 0 squared. Dy over dx squared is 0 squared. All of this becomes meaningless because it's equal to a 1. Dx, you have essentially 2 pi r, and then it goes back to the original procedure I showed you, a very easy antiderivative and integral from which you will get 2 pi r h, which you see right over here. So you can see the two ways, the intuitive way, the circumference going all the way across, and this right here, which is the same thing but it's a formalized approach. The most important thing to remember here, dy over dx, is the derivative of this, the implicit differentiation of this equation, y equals r, dy over dx is equal to 0. This goes away. The only thing which remains is this from your formula, and that integrates along with your x coming in. That's it for this particular video. Keep in mind 2 pi r h plus 2 pi r square equals the surface area of a cylinder, whether it's horizontal, whether it's vertical. I'm showing you in this video everything with regards to dx. Have a good day.